Hello, everyone. Welcome to the DePIN Podcast. I'm a host, Tom Trowbridge. Thrilled to be here today with Ryan Connor from Blockworks. Welcome, Ryan.
Yeah, Tom, thanks for having me.
So, Ryan, let's dive into it right away. First, for people that don't know, tell us about Blockworks, and then we'll get into what you're doing.
Yeah, totally. So Blockworks is a leading media company in the crypto space. We have podcasts, we have news, and we have research. So the research team is just under 2 years old, I believe. We're quickly shooting to the top of the leaderboard there. On the research team, I mostly cover DePIN. But, as a consequence of just the crypto space kind of being all over the place, I know a little bit of everything.
Fair enough. Yeah, I mean, I would think that you start broad, but as the crypto space expands, your focus may get DePIN kind of expands also, right? So just being focused on crypto was enough for at one period. Now you got to focus within crypto in a sector, and that may even get narrower. But let's start with DePIN. One things I originally, I always ask guests to start off with is, how do you define DePIN?
Yeah, so super important question for narrowing down like the opportunity set. I think that if you're a startup and you're looking to leverage crypto rails, you will use crypto for one of two reasons. One is for like the credible neutral back end that crypto rails provide. The next is to give people tokens to do things. So incentivize people to do something for your application. You see a lot of that in crypto, and DePIN definitely fits into that bucket. But to get more specific, like the interesting thing about DePIN is the focus on hardware to do basically anything but validate blocks. So this is a definition first put forward by Masari, so hat tip to them. But to me, DePIN are projects that use token incentives to incentivize the upkeep, maintenance of hardware to do anything but validate blocks.
That's interesting, because I thought I had a pretty broad definition, but that is actually a much more expansive one that I have a difficult time arguing with. So mine is slightly more precise. Tell me what you think. It's a crowdsourced physical infrastructure bound together by a common software layer into a network that's secured and incented by crypto economics.
Yeah, I mean, I think that's fair. I think that I spent 7 years in TradFi. The definitions don't change because everything's basically set in stone and moves slow. Crypto is in constant flux. I'm sure that when we do this again in a year, we'll both have like two different definitions.
I hope not. And that's actually something that I'm focused on, because whenever sector becomes hot, everyone tries to jump into that sector, and all of a sudden everyone is in the hot sector. And so I'm trying to hammer away at a definition to help prevent that, because if a sector, any sector, expands too broadly, then it becomes meaningless. And so I think it's incumbent on us, and you particularly in the research role you're wearing, to kind of be somewhat of a gatekeeper and be like, hey, XYZ is a great project, adding a ton of value. It's fascinating, but it's not DePIN. And that is, hopefully people aren't insulted or harmed by that. But I do think we have to, whether it's DeFi, whether it's AI, pick your group, your sector. If we don't have definitions, then the names stop becoming meaningful.
Yeah, I totally agree. It's so important in investing to be precise in your language and your theses and your classifications because it aids in decision making. And that's definitely something that Blockworks Research is focused on within the industry: standardization of the language and also metrics.
Well, let's talk about your research then, because I know you've been focused a lot on compute providers. But tell us about kind of first, where you started to focus, why you focused there, and then let's dig into that research.
Yeah, totally. So I guess like with my career, I started out as a macro investor, but increasingly got interested in the technology space over that time frame. There just seemed to be all the action was going on there, right? Versus like the broader equity space. In 2016, 2017, became interested in the hyperscalers, just like basically thinking back to an old Mark Andreessen note, Software is Eating the World, where he talks about the major cost advantages of cloud computing and how it was very obvious that everyone would be there. And then looking around in 2016 and 2017, seeing 20% CAGRs going forward and being like, wow, Mark absolutely nailed this one. So the hyperscalers were like super interesting to me. From then got interested in the semiconductor space, 2019, 2020. It became increasingly clear that like AI was somewhere in the future. If you were paying attention to like the Stanford had an annual AI report, I believe that started in 2018. And when you would extrapolate like the performance gains in terms of like image classification or like performance on test scores and reasoning ability, like you would get to some future state within the next 5-10 years where like AI was really taking off and beating humans at across a lot of dimensions. So like the obvious beneficiary there was semiconductors, and became increasingly interested in that space. As a consequence of that, did some hardware investing, got increasingly interested in crypto. And when I was pitching crypto to my old firm, the things that stuck with the investment committee were not like, surprisingly, it wasn't DeFi. It wasn't Bitcoin store of value. It was really like these things that were generating revenue, providing services that like made sense, that like could map to the real world. Live Peer, Filecoin, Helium. Those were the things that made sense to TradFi investors. So that's where I spent a lot of my time. It's just like, and messaging around like and understanding those what are now considered DePIN projects. That all really accelerated with AI. So the ChatGPT moment, I think it became clear to everyone that AI was going to be a big deal. And about 3 to 5 months later, it became increasingly clear that we needed a new way to leverage compute. So like quickly taking a step back to make the case for, you need to understand what AI is and why AI is here to stay, to understand why like compute DePINs make so much sense. So put simply, I think AI transformer models, diffusion models, they are leading to step function changes in productivity, and they're leading to exceptional business outcomes, right? We all know the productivity gains that we are increasingly seeing with LLMs. And like we are all seeing the very early innings of exceptional business outcomes driven by these LLMs and similar AI models that require heavy computational resources. So like my favorite example is Google, where Google runs a lot of data centers. For the last 25 years, they've had the best engineering talent, and they have been, over those decades, applying that engineering talent to minimize their utility bill. And then around 2018, 2019, Google unleashed AI on energy consumption in data centers, and they said, "Hey, solve this better than our engineers could solve over a 2-decade time frame." And the AI model improved energy efficiency in those data centers by 30%. So it bested compounding knowledge of the best engineers on the planet over an N-month time frame by 30%. Really exceptional business outcome. And we're seeing a lot of those in medicine and finance and all sorts of sectors today, which I think is like super important. Now, the reason why compute matters more than ever is like everyone knows like the computational resources that it takes to, one, train these models, build these models, and then to run these models in production. But maybe I think it makes sense to compare and contrast the current state of like software development with like the AI future of software development, where in the old state, like you weren't really thinking about scaling your hardware resources, and you couldn't really just throw more hardware resources, computation at a problem to solve the problem or to make the product better. That is completely flipped on its head with AI. So if you look at the OpenAI paper scaling laws that came out in 2020, there is a direct relationship between the intelligence of the model and the amount of data and computational resources compute you throw at the problem. So for the first time ever, developers are actually rewarded for just throwing more compute at a problem, for just crunching more data. And like very loosely, scaling laws, that paper says that in order to double the performance of an AI model, you should 10x the compute and 10x the data. Now, like that's changed over the last 2 years. We're finding out that that's not exactly what you need to do, but directionally, like that's the case. So for the first time ever, we are creating these systems that are enabling step function improvements in human abilities and business outcomes. And all we really need to do, base level, is to throw more and more computational resources at that problem. And that's why compute DePINs are so interesting today, because we live in a world where computational resources are scarce. There are queues in the data center for AI compute. And in totality, we actually under leverage total compute resources due to latent compute sitting out in the world. And compute DePINs sit in the right place to use token incentives to leverage those underutilized compute resources and kind of like solve this compute shortage problem and like bring AI forward.
I mean, that is a extensive and thoughtful answer on compute. I've got two comments on it. The first one, I guess, is another way to phrase what you're saying a little bit earlier. Was it roughly every doubling of computation power thrown at an AI model results in less incremental gain?
Correct.
Right. So which means to have the same trajectory of growth of gain, you have to be your compute power demands and power demands go up very, very steeply, almost logarithmically. So is that fair?
That's fair, and it is changing today. I can't say that I'm up with all the research, but we're finding ways to make these things better with less compute and less data. So, for example, if you look at Microsoft's latest small LLM called Phi, what they've done is they've used more compute, a higher proportion of compute than they are using data, but they're using higher quality data. So, like, what that tells me is we're getting much more efficient at creating these models. But I think the underlying trend here with that you see in technology markets broadly is Jevons paradox. So Jevons paradox basically states that even if you bring the cost of a resource lower, you will not actually consume less of that resource. You'll consume more because now it's more accessible to more people and you figure out how to do more important things. We've seen that in SaaS. We've seen that in cloud computing. We've seen that in streaming. We've seen that in block space in the crypto markets today. And
you see it in physical infrastructure, right? You create wider highways, traffic doesn't go away because more people drive on them. So I'm familiar with that for sure. The other component here, though, and that's computing on a GPU side, primarily for AI. Yep. But computing and the bulk of computing in the world right now is CPU based, right? And so I think, there are real reasons for decentralized CPU as well. But it sounds like you're most focused on the GPU side, given the growth and the demand there.
Yeah. So when we look out into the market today, that's where the capital has been raised. For very obvious reasons, right? Like these new models that are super hot, whether or not they are the models of tomorrow, like state spatial models may overtake transformer models. Like we don't know what the future is going to hold, but the models today, the transformer model, LLMs, even if that's not the best case, like a lot of money is being thrown at the problem. So the primary focus today is these GPU networks. Now, like totally agree, CPUs are just as important. If you think of like simulations, rather than transformer models. They very much favor CPUs because the dependencies are serial and not as easily parallelizable. So if you look at the major supercomputers today, they actually run on thousands and thousands of CPUs, not GPUs. So the CPU market is just as important. And you're kind of seeing compute DePINs think about that today. We know Fluence is thinking about that today, or just like how important CPUs are in general. We see IONET like incentivizing CPUs to come onto the network because they are useful to a degree in AI inferencing. So yeah, CPUs are very much overlooked. I would agree.
Yeah, and if you think about the bulk of the computation that happens on the planet today, there's something like 3 billion CPUs out there, right? It's an enormous number. And obviously they're not all used, and some are old, and there are different number of cores, but it will take a lot of GPU doubling for many years to approach that amount. And all the stuff we do, all the pharma, data analysis, all the drug analysis, all of this stuff that's heavy computational outside of LLMs is all done on CPUs.
Data analytics and data processing. Yep.
And that's where Fluence is now. And we are, though, exploring, we can't ignore the GPU market. And so it's something we're clearly exploring. But tell us about some of the research you've done, some of the companies you've looked at, kind of different models. How do you think about this decentralized compute marketplace?
Yeah, totally. So as far as like models go, I guess let's like maybe start with token models. I think that there are 3 general token models that we're seeing in the compute DePIN space today. The first is like just the classic burden-mint equilibrium model, or the commodity model that you're seeing, that you've seen projects inside and outside of the compute DePIN space leverage. So you issue tokens for people to contribute their resources to the network, and you make sure that the costs to the demand side are denominated in USD. And then when that resource is paid for by consumers, instead of giving the USD directly to the suppliers of the network or those who provision the service, you use that USD to buy and burn the native token off of the market. So acting as a floor for demand in that asset on the market, and ultimately accruing value to that token, which I think is like a super useful model. The next model that we're seeing in the market is, I think it's called the work model, or like the medallion model, right? Where if you need your network to be Sybil resistant, it's very, very easy for an engineer to take a GPU, a high performance one, spin up a bunch of VMs on it, and spoof your network and telling it that you have more computational resources than you actually do. So what you can do is you can tell the supply side of your network, hey, you need to buy the native token, you need to stake it, and then therefore you have the right to provide the service to the network, kind of like a taxi medallion. That's another pretty useful model. The next model that we're seeing is call it like a currency discount model, where there's like a native token, it's issued to the supply side. Then if the demand side wants to buy resources from the network, they have to pay for it, and they can pay for it in USD, but if they pay for it in native currency, they get a discount. So those are like the 3 like primary token models like that we're seeing.
And just as a question on those,
yeah,
if you're not using stake to provide trust, as in it looked like, because those 3 models you mentioned, only stake is, I think, only in the second one. How is trust being provided or attested?
Yeah,
or is it reputation Web 2 world?
There are reputation models. There are like proof of work kind of models. So like sending specific jobs to these machines and make sure they actually can execute them. I'm a little fuzzy on the details of actually how those work, but that's how we're seeing networks like attack the Sybils, right? Outside of stake.
Fair enough. I mean, because our perspective is, in general, in crypto, if it's not a proof of work, if it's a proof of the stake is what provides trust. And so that's how we set up with Fluence, where your stake is what allows, users who don't know you to trust that you will provide that computation. And then clearly there is verification on top of that. But that verification, if you don't have the stake, there's not much consequences for the verification. You may lose some trust points, but you're not going to lose any economic value, or at least less economic value, I suppose, than if there's stake. So we think stake is a critical part of proving trust. And that's, that's obviously a well-known model in the space. The other thing that's interesting, I think you mentioned on the dollar side, is one lesson that we've taken is that we want to pay providers in something that's as predictable as possible. Because if it's just purely denominated in token and it falls and the fiat value doesn't cover their costs, you're going to lose your providers. And so in Fluence, we actually have it so that the rewards recalibrate based on the token price to approximate a certain, around $10 per core per month. And it will never be that exactly because the token is going to fluctuate. There's a release, investing, et cetera. But we're trying to provide some linkage to a value that is relevant to the compute providers.
Yeah, I like the Fluence model. I think it seems to be like one of the most advanced that I've seen. And like the real benefits, like, look, everyone talks about first mover advantage. Like last mover advantage is a thing too. You get to see how it was tried across many different verticals. You get to see all the dimensions play out, and you kind of get to, you have a grab bag of features to pull from. You have different knobs to pull that the early participants in the ecosystem did not. So yeah, I think that's super. I like the Fluence model a lot. I also think it's interesting, like stake is very, very powerful. It's why proof of stake systems work so well today. And like the thing that, like the market kind of, general discourse kind of ignores this, but like everyone talks about how important incentives are, like show me the incentive and I'll show you the outcome. But like positive incentives, like they're effective, but like negative incentives are pretty effective too. They might actually be even more effective because of loss aversion. So yeah, I agree. Stake is a very powerful, I guess let's call it crypto economic primitive.
And so let's get into more detail on some of the projects you research, some of the other, models kind of outside the crypto, the token economy. What are some, projects you spend a lot of time on? What is interesting? Where have you seen any traction? Where are you going to do more research? Help us kind of understand that whole kind of path.
Totally. So just like from a high level, the way that we really think about the space is at the intersection of hardware specialization and latency sensitivity. And the reason that we feel that way is because if you look at like all the workflows in the cloud, you'll find that the hardware that you have will determine the workloads that people want to do on top. So for example, like simulations, they need a bunch of CPUs. Like you're not going to do those over GPUs. You're going to do those on CPUs. So that's parallelism versus serial dependencies. Memory intensity, right? Like an LLM inference needs much more memory than a ray tracing job. It just does. There's specialized hardware. So if you think of like Bitcoin mining, and like that's a very obvious one, like that needs ASICs. And then like most importantly, like latency sensitivity. So one of my favorite kind of anecdotes that really guides a lot of my thinking is this Google study from, I believe it was like 2017 or 2018, where they noted that consumer disutility with an application increases every 15 milliseconds, right? So with every 15 millisecond of latency, a consumer is more likely to say, this is a bad experience, I'm closing the app. So for compute DePINs that are leveraging latent hardware, consumer hardware, like not bleeding edge, not leading edge hardware, latency sensitivity is something that the end application really needs to think about, and that's going to affect who's going to use these networks and who isn't. Now, like if you look like a network like Fluence or some of the relationships that IONET has or that Akash has, you find that these networks are focusing on these like professional data center operators. So here, like latency sensitive applications, they're more likely to use these networks. Whereas if you look at a network like Render, who generally has RTX 3090s and 4090s consumer hardware, like they're pretty decent for inferencing. You definitely don't want to train on them, but there's going to be they're going to be much more. There's going to be more latency there than there are on the leading edge and bleeding edge in the professional data center that projects like Fluence is leveraging. So the workloads that a render node is going to be targeting has to be very different. That end consumer has to be different. That go-to-market has to be very different. And that's what we think is like really interesting about these networks is like the first and continuing customer is going to be very much determined by that intersection of hardware specialization and latency.
I mean, that's a fascinating abstraction of compute and of applicability. I find that that's super interesting. And I think, one thing we've seen over the course of crypto evolution is the professionalization of hardware providers, whether it was Bitcoin mining that started off in people's basements and now is purpose-built data centers run by publicly traded companies, right? You've seen that all across. You've seen it with you've even seen it with Filecoin, right? People's computers, now there's Filecoin miners, raise money, purely focused on mining Filecoin, storing things, right? So you see that across. Our perspective was that will happen quickly in compute as well. Candidly, people thought about decentralized networks as very consumer focused. And we specifically started targeting and launching with top tier data centers to make it clear that this was a performant network built on performant hardware that people could rely and trust on and not have to wait for that evolution. Now, we clearly want to open it up to individual users, and we will do that. But I think once it's easier to open up to them, once we have the reputation and actually metrics of reliability before that.
I totally agree. Like, I think that the Bitcoin example is a fantastic example, but even when you look in DePIN today, you're seeing that increased level of professionalization across a number of projects. I mean, you can look at Akash, right? They used to have a handful of CPUs, all contributed by hobbyists, and now they're focusing on hopefully independent data centers with A100s and H100s. You can look at HiveMapper. HiveMapper started with hobbyists who were just like slapped on a dash cam on their way to work, on like Uber Lyft drivers, and increasingly they're going to be targeting fleets. And I think you're going to see the primary user on the supply side of that network. They're going to be fleet managers and fleet drivers. You even see it. You see it in every single market where there are returns, where there are economics and there are returns to scale. So even like Airbnb. Like, I am a sole Airbnb proprietor, and we know people in the same market that like it is a financialized and professional market. There are people that own multiple homes. There are service providers that help you manage them. It gets increasingly professionalized over time. And so, like, why would we expect anything else in these markets that have economics and that scale quite well? Like, you're going to have that professionalization, and it shouldn't be fought. It's going to enable a higher quality product for the end customer, and that's what you want at the end of the day. You want success, and I think professionalization of the supply side is important for that.
And I agree with it. And what I'd also add to it is that if you are an early consumer user, you will benefit from that because of your tokens will become more valuable over time. So if you are an early provider of service to the network and eventually becomes too professional, in a way that's a shame because you're no longer able to as economically provide the same service or be rewarded the same level, but that should also go hand in hand with the network use increasing, the utility increasing, and the value of the network increasing. And so if you've held on to your tokens, as hopefully you do, that should be a significant reward for providing that early bootstrap service and access or whatever it was in the beginning when it was very important to do so.
Yeah, I totally agree. That's one of the cool things about these networks is that they reward participants in proportion with their contributions and in proportion with the amount of risk that they take. So those first contributors to Fluence or to IO or to Helium or whatever, they took the most risk with their time, with their capital, with their hardware. They should be rewarded as such. I think the other important part too is like, think of a decentralized compute network. Think of who like your ideal customers are and think about how uncomfortable they potentially are with just sending a workload to like some regular Joe's computer. Like it's not something that they've ever heard of before. So you need a bridge. Like forget ideology, forget that we want to be decentralized. Like this thing needs to survive at all. Like it needs to live. And the best way to handhold that client will be to say like, hey, yeah, maybe down the road, we'll send your job to the RTX 3090, like sitting in some gamer's computer if you need it. But we also have professional data center partners that look and feel a lot like Web 2. Like that's how you're gonna land that client. That's how you're gonna get that contract. That's how you're gonna get usage and drive value to the token. So I think it's really important that that crypto not look down on the professional service providers because they are a really important Web 2 bridge. Call it like Web 2.5. Let's bring that term back. I like that framing, and it's important for these networks to survive.
Well, listen, you mentioned a couple projects. You mentioned Akash, you mentioned IO.net. Anything, obviously both, IO started off being more GPU focused. It's adding CPUs, and kind of the reverse is true for Akash as far as I know. Anything you want to talk to or get into more depth on either one of them or another kind of compute DePIN project or protocol out there?
I think it's more interesting to talk about a specific market that I think that all compute DePINs have an inherent both product and cost advantage, kind of like a natural first customer. And again, this is applicable to really any compute DePIN network because any compute DePIN network can run some level of inference, which is really all you need to tackle this market. And that market is synthetic data. So GPT-4 was trained on like quote unquote, like all the world's data, like in human history. And like, that's not exactly true, but it's like directionally true, right? It's like basically most of it. We are running out of data, and more importantly, we're running out of high quality data. So if you look at the estimates on like when we are going to run out of data to train these models, it's somewhere between 2027 and like early 2030. And as AI research progresses, we're finding that actually like Reddit's data set of just like shit posting and like chatting is actually not that valuable. What's valuable is like really high quality data given by professionals and like hyper intelligent people, and also edge case data, which there's not a lot of edge case data out there by definition. So one of the most interesting products on the market, and it's a Web 2 product, it's NVIDIA's Drive platform. And like, why is it interesting to me? NVIDIA's Drive platform, like they provide all the software and hardware for ADAS and autonomous vehicles, but they also provide synthetic data. So NVIDIA is a gaming company. Like they make gaming they make gaming graphics better than anyone else. And they found that one way to train a vehicle or an autonomous vehicle to drive better is to simply feed it driving simulations based on NVIDIA's GPUs and the graphics that they generate. So like, why is this better? A single Tesla vehicle will, for maybe in its entire lifetime, never see a little girl running out to the middle of the road to catch her ball, right? But NVIDIA can generate that same scene hundreds of thousands, millions, or billions of times and feed that to an autonomous driving system and how to learn to operate in that environment. And that is what's most important actually for driving. Same thing applies to like medical data. What you want to really focus on are the edge cases, these underserved markets. Because right now we just like treat the sickest median patient. But if you can inject high fidelity synthetic data into a data set, we might be able to find something out about those edge cases. And we're seeing that happen in practice today. So the fact that synthetic data can help us adjust for the edge cases, it can help us tackle biases in models, it can help us avoid running out of data. Synthetic data is super important. It will become increasingly important over time. And compute DePIN networks actually have a structural cost advantage in generating this data because they do not need to compete with the data centers in doing this. It's like we've done the math on this and it's on the Blockworks Research website, but it's like 1/20th to 1/10th the cost to run an inference on some of these networks. That's a major cost advantage for generating synthetic data on a decentralized network than on the cloud. And frankly, like an RTX 3090 and 4090, it's basically the same thing as running inference on an A100. You don't need top of the line hardware to run inference, especially when you can run a lot of these inferences to generate this synthetic data in parallel. And then the most important thing here is like, this is not latency sensitive, which is where some compute DePINs may have a disadvantage because they are focusing on that hardware. There's no consumer waiting on the ping back. All we need is like the synthetic data to be high fidelity, to tackle those edge cases, to get that mix of statistical characteristics that we need to move these models in the right direction to make these models better and tackle these problems. So this is a very like obvious wedge into the market that I think that compute DePINs should increasingly focus on in their go-to-market. And I think they all can, which is really interesting.
So, yeah, that's fascinating. And your Tesla example is a great one, right? That is super clear. You can understand how that works. I'm less clear on the other ones. I'm not as clear on how you can synthetically create a medical edge case or an edge case relating to other kind of more political or social related topics, which I think you implied. How can you give some examples of those?
So it is as perplexing to me as it is everyone else. Like I've talked to top hedge fund managers about this who invest in the more scientific areas of the market. We've talked to people that build these networks and do these AI models. It doesn't make sense, right? Like you would think that if you like, how could you it seems so circular that it's very hard to do. But if you look at a company like Scale AI, a large part of their business is generating the synthetic data for major LLM companies like OpenAI and Anthropic. They're working with everyone and they have a synthetic data product. So like the proof of concept is there and we're seeing it in like the academic papers. So if you read these abstracts on synthetic data, like this stuff is gaining speed. And because these models, they need 10x the compute to double the performance, 10x the data to double that performance. The compute side is like more or less like we can figure that out, right? It's just like more and more chips. The data side, like you could actually bump up against that wall. So really smart people are getting really creative in how they generate this stuff. It's beyond it. It's beyond me. It's moon math to me. But from what I'm seeing from some of the smartest people in the industry, like they're really excited about it.
Well, that's really interesting. So appreciate you introducing that concept here. It brings to mind for me the added importance of transparency and openness, because we've seen what these models using data sets that aren't transparent or open, how some of the outputs can be quite biased, quite obviously biased, whether you're talking about some of the ChatGPT political bias that people have observed and researchers have kind of documented, or the image creation of Google Gemini, which was kind of absurd. And so you run the risk, I guess, without transparency in compounding those if you're inputting synthetic data into the model. So I guess that's sort of, while it's a fascinating concept to explore, I'm sure it's the future, that to me is even raises the scrutiny and importance of transparency and openness even higher.
Yeah, it's the transparency, openness. It's an interesting part of the market. I think it's Morpheus is a project that is focused on creating like a non-biased LLM. They're using open source models and like their own research to create like an open LLM that you don't have to worry about lying to you about important subjects like what Google did and like potentially what OpenAI does in Gemini. I wonder, and maybe you can give me some feedback on this, you might be closer to this than me. I wonder how big of a market that is. So when I look at the market for information or for chat or for entertainment, it's all highly biased. Now, like a lot of that's consumer use cases, right? But like when I look at the way that people consume media, they often want bias in their media. They want bias in the news that's presented to them. Now, maybe like Morpheus causes some like shift in consumer preference. But I don't know. It's hard for me to envision a world where we're all like consumers are all just clamoring for non-biased information sources.
Well, listen, it's a fascinating topic, and listen, it's not as if the people watching CNN or Fox are outraged that there's a bias on either one of those, right? They've chosen them. Right. So I grasp that point without a doubt, but I think this is a different one because there you know the bias, and the bias is written on the tin. And so there's two elements. There's a bias and how open is it? And so it's one thing if there's a bias and it's clear and people make that choice. The dangerous part is when there's a attestation or a representation that things are not biased, and then there actually is a bias underneath. That's the part that I think is a problem. And then the other point is that you may have a bias when you go to hear your political commentary on Fox, but if you want to do oncology research for your 5-year-old, you probably want the most accurate, most trusted data, and are probably not going to want to deal with any kind of bias of any kind. So there are different use cases, and these LLMs, by the way, are going to become more and more important, a single source of truth, not just for politics, right, but for legal contracts. I use them to make contracts myself, for medical diagnosis, for all kinds of things. And so I parse that into, is there a clear bias? Is there a bias? Is it open and knowable? One thing, good, bad, maybe people like it, maybe don't. And the next is, okay, what are the use cases for which I really want something that is as data focused as possible?
Yeah, that's interesting. So when I do a lot of my research, I will be using Claude. I'll be using ChatGPT. I'll even use some Google Gemini, and I'll often like take a committee approach, right? So I'll copy paste the same question to all three, and increasingly I'm using Morpheus, right? So I'm using this committee approach across all these potentially biased sources, and then I'm also leveraging Morpheus's opinion to kind of give me like a committee, like what is the answer here? So that's super interesting. There's another product, and I'm not an expert here. I intend to be soon, I hope, because it is an interesting concept. But there's this project called Grass that is doing data scraping and like hashing these values on a Solana-based L2, and is basically doing this to mitigate data poisoning attacks. So basically, if you're a website and you can figure out if a scraper is not listening to your robots.txt, you can inject data that the model doesn't want, that will bias it, that will cause it to do things that that the scraper doesn't want it to do. So Grass kind of uses different IP addresses to obfuscate that, and then hashes these values together and guarantees that that data is free of data poisoning attacks, which is useful for LLM training. And they want to make this data public. They want it to be like this open source repository where you can go to Grass and you can like be sure that you have this fair, objective, transparent web scrape data free of data poisoning attacks, which I think is a super interesting concept and like fits well in this like this crypto insured trust model for data on the internet.
Yeah, listen, I agree. That is definitely interesting, and I want them to be successful. I think that's an important element. With regard to that use case that was sort of all started, which is basically this, what do you call synthetic data? Fascinating use case for models. Are there either other use cases or other kind of compute pieces in your research you uncovered that you'd like to discuss as well?
Yeah, so I think that one of the most interesting kind of go-to-markets for these projects is like this kind of like variable load service that they can provide for independent data centers. I think that, when you dig into the operational efficiencies of like these data centers that might experience a little bit more downtime than the hyperscalers, that might not have like, I think it's called concurrent maintenance. So when like a server goes down, someone's in there and like trying to fix the problem. These independent data centers are like kind of forgotten. But they have a lot of kind of like latent capacity that they need distribution for, right? And crypto's getting to a really interesting spot where, look, there's going to be a ton of shots on goal with AI inference. You see it with like intents, you see it with agents, you see it with gaming. You see it with projects like Morpheus, like crypto technologists, like they love this stuff. They're going to push the limits. They are going to take shots on goal here, and they don't want to use the hyperscalers. So the hyperscalers might need that distribution, so independent data centers might need that distribution. And there's going to be a lot of computation going into these smart contracts. So like, I think that from like a go-to-market standpoint, like crypto natives are going to be a surprisingly big market, or at least a first customer for a lot of these compute DePINs, and that there's a lot of latent reliable supply in these independent data centers in the United States that's underutilized, that like compute DePINs can effectively act as like a front end or distribution engine for, which I think is a really interesting go-to-market.
I mean, I think that's exactly what we see at Fluence for sure, especially if you add it to if you add the serverless piece to it, because you can just be a distribution engine for sure, and that's great. You have distribution that the data centers don't have, great, but if you also offer a product like a serverless that they don't have, now you really are adding some value to their kind of hardware inventory. And to their product suite. So that's something that we're sort of quite aware of as well. And frankly, I get the point on a variety of networks that are looking to increase the compute, mainly CPU usage for block production for a variety of tasks. So definitely see that also. And it'd be great to build up that customer base, no doubt.
Yeah, that's really interesting. I think that one of the big problems with compute DePIN networks is that as a user, you lose a lot of like the elastic compute, like the compute that automatically scales up. You lose the data center tooling. So like those partnerships for compute DePINs, again, that's like that Web 2.5 bridging. Like you kind of need that for for developers that are used to like the efficiency of the cloud. Serverless is super important. I don't think like developers can live with that nowadays. Actually, they're so used to it.
Yep. And I'd just go a step further, which is, and make another comment too. But first step is that the world is becoming more episodic and reacting faster and harder to predict, all of which make serverless that much more of a relevant solution for anything. So it sort of makes less and less sense to have compute resources dedicated online, because you just don't know when demand is going to be for that more and more, for many more and more projects. The other thing I want to say, and kind of get your perspective on, with regard to the importance of DePIN, and you mentioned, HiveMapper, and I think it was Ariel who was on this, who basically said that he thinks DePIN has to succeed for crypto to work. And that's a very big statement. And I'm not sure I go quite that far. I think Bitcoin can succeed independently. I think DeFi can succeed independently. Real world asset, RWA, tokenization could probably succeed independently. But I would agree with is that, and you kind of, this turns back to almost one of the beginning comments you made, is that DePIN has the potential to onboard the next generation of users. And it is so much easier to understand than most of the more technical DeFi or other related subsectors. And so the monetization related to people's assets is something that is rather intuitive. And so it has a real chance here to become something big.
Yeah, I totally agree. It was a while back. I can't remember when, but I tweeted like, look, if all crypto, and this was like during the depths of the bear, I tweeted, if all crypto ever becomes is like 20 to 40 DePIN projects that are super successful, like will crypto have succeeded? And I think yes. I think like unequivocally yes. Like you see kind of the cost, like you see what Fluence is doing as a distribution mechanism for like the serverless model. You see like the cost improvements that Helium is bringing for consumers around 5G. You see like the increased freshness that Helium, that HiveMapper brings to like map production and map data. Like there's something there. Like the token enables something special, a cost or product advantage. And again, if we only have like 20 of those things and they're pretty successful and that's all crypto ever becomes, like I think that that's great. I don't know if it's going to be that way, but I think that that's fine. I think one like really interesting observation around like DePIN and whether or not it becomes popular or whether or not it becomes mainstream and like onboards like traditional financial investors is like Bill Ackman, I think it was in 2022, tweeted out that he had personally bought the HNT token because he understood the value it provided and he understood like the model, like it made sense to him. Now this is Bill Ackman. Bill Ackman is a proper Warren Buffett style value investor. He's looking for stable business model. He's looking for like obvious compounding. He's looking for things that'll be around in 10 or 20 years. He's looking for economic moats. He's looking for value accrual. And he bought the HNT token in his personal account. I think that says a lot about what DePIN can be and how it could really change the narrative once you have like 2 or 3 of these projects that have been really successful. The whole narrative could shift. Like you'd be like, well, crypto was nothing and then DeFi happened and then everyone in crypto forgot that crypto was nothing. Right. So like you'd be surprised or it was like payments on Bitcoin. And then everyone forgot how it was payments on Bitcoin. And all of a sudden it became DeFi for like a year and a half. Narratives can change really, really fast if like big impactful thought leaders like change their positioning on things or like one app is successful. And I think like there's a non-zero chance that starts in DePIN because again, it's just such a natural fit to traditional investors. Again, like I said, my former investment committee, like that, those are the things that they understood. It wasn't like yield farming. It wasn't perpetuals. It wasn't perpetual options, which I thought were really cool, but never took off. It was DePIN like things. It was like decentralized VPN, right? Like those are the things that like TradFi understand. So I think DeFi could be a great bridge. And I think that if DePIN's really successful, like the whole narrative can change like very, very quickly.
So tell us how to follow you, how to follow Blockworks. What are some research reports you would steer people to get some more of your thinking on compute or DePIN in general?
Yeah, totally. So I am at Ryan R. Connor _ on Twitter. Same handle on Farcaster. Blockworks Research. We've been around for a bit now, but I think that we're best in class. You can follow us on blockworksresearch.com. I've written 4 reports now. Compute DePIN, it's free. Anyone can take a look. The rest are behind paywalls. Pith, Hive Mapper, and the TON ecosystem. Look, I'm hyper bullish on the Blockworks Research team. I think our subs love us. I think that I've never been around a smarter group of guys. So highly encourage, come check us out because I think the team has a lot to offer.
Fantastic. And any other reports you're working on? Anything else people should be aware that's going to come out in the next couple of months, quarters?
Yeah, I want to focus. Look, the AI. Everyone's talking about crypto AI, and I get it. Like, combine these two technologies, cool things can happen. But there's a different kind of narrative on crypto AI, and it's the market structures that evolve because of AI. So one is compute markets, the other is data markets, and then the other is energy markets. And we're seeing a lot of shots on goal in compute. We're kind of seeing some things around data DAO, but I would like to see some things around synthetic data. So if there are any entrepreneurs working on that, I'd love to talk to you. And then energy networks, like, the U.S. hasn't increased. I mean, the U.S. has been increasing energy production by like less than 2% for like the last 20 years. And all of a sudden we're going to have to produce at like a 6% CAGR. Like, there are shots on goal there for DePIN founders and investors. So if anyone's working on that space, I'd love to talk to you too and hit reports on both of those topics.
Fantastic. Well, Ryan, thank you for joining. Really appreciate it. And look forward to having you on again, and pick your time frame. But another year or two of research under your belt, it should be interesting to see kind of how your perspective has remained the same or changed. But thank you again for being on.
Thanks a bunch, Tom. I had a blast. This was a lot of fun.